Okay, so let's see if I can actually do this like I used to do. And hopefully the pen's a little faster today. So let's pick a color. First question. Jack spent $80 out of its $140 allowance. What percent did he spend? So here we go. Here's your setup. The most important thing is setting this up properly. $80, 140, and here the percent that goes over 100 is the part that we want. So we'll leave this like a question mark over here. Okay. No relationship between 140 and 100. Okay. So the easiest thing you could have done probably is multiply top and bottom by 10. And that would have given you 1,400 here and 800 on top. Now, you're not going to use this anymore. Okay, you're going to use your new fraction here, 800 over 1,400. And there's a nice relationship here. Divide by 14. And you're going to take the top and divide by 14. So 800 divided by 14, if I'm not mistaken from what I remember in class, about 57.1, and you can stop around there. Okay, 57.1%. Question 2, 35% of the students, so let's set this up. Here's my proportion, 100, blank over here, 35%, so that goes on top of the 100. And we want the equivalent, let's see, and there are 120 students on the bus, so that the total number of students, in this case, on the bus is 120. And we want to know what 35% equals. Alright, no relationship between 120 and 100. This one you could have divided 35 by 5 and you get 7. And 100 divided by 5 you get 20. So this one you didn't have to go higher. Going lower worked. Now there is a relationship between 20 and 100 times 6. And obviously you have to apply that same on top times 6. So you get a total of 42. So out of the 120 kids on the bus, that's a big bus by the way, 42 have blue eyes. Next one, 16 teachers are going on a school trip. They represent 40% of all the teachers in the school. So again, let's set this up. 100 over here. We know that 40%, and 40% means 16 teachers. So how many teachers are in that whole school? No relationship between 40 and 16. Okay, so an easy way to do this was to divide this by 10. 40 divided by 10 gave you 4. And here, 100 divided by 10 gave you 10. Nice relationship between 4 and 16. 4 to become 16 is times 4. And you're going to apply that same thing at the bottom, which would be times 4. And 10 times 4 gives you 40. So, how many teachers are in the school? There are 40 teachers in the school. Okay. Next one. Determine if the numbers are part of the counting, whole, integer, rational, or irrational set. Okay, so I'm going to do this very quickly. 4. I'm not going to write it out. I'm going to use abbreviation. So 4 is a counting number. C for counting number. It's also a whole, and it's an integer, and it's a rational. Let's do the one next to it. 0.03. It's a rational number because it's a decimal it's a terminating decimal. Okay, a decimal that ends, doesn't go on. So a decimal that ends is a rational number. You can put that as a fraction, 3 over 100. -5, it's an integer and it's rational. -3/5. Okay, -3/5 can be written as a decimal. Okay, so and if you change that to a decimal, you will notice that it's a terminating decimal, 0.60, and if it's a decimal that ends, it's a rational. 4.23 is also a terminating decimal. It doesn't go on forever. Okay, and it's one that ends, and any decimal that ends is rational. Let me go over here. 2.44 with a little bar notation on top here. It means that the 44 repeats. I should have done 44, but the 4 repeats forever and ever. So if it's decimal that repeats and goes on forever, it's also rational. 2 and 1/6. Okay, if it's a fraction, it's rational. And the last decimal, I'm not even going to write it out. It's 1.23 4987, and you can tell that it goes on forever. And it does not repeat. Okay, a decimal that does not repeat and goes on forever is irrational. Clear? Next one. Let's write this out. Negative 23. And negative 23 is greater than negative 35. Why? Because negative 23 is to the right. Okay, if you were to do a number line, I'm not going to do a number line for all of them. But if that's a number line, negative 23 will be around here. And negative 35 would be here. Okay, the number on the right is always the bigger one. Okay, and let's... Alright, so next one, 2.45 and 2 3/7. Okay, I would definitely change the 3/7 into a decimal. Okay, and 3/7. If you divide 3 divided by 7, you would get 0.42. Okay, and you would write this like this. Actually, probably be 2.43 rounded because there's an 8 that follows. But nevertheless, you can clearly tell, even if you didn't round this to 2.43, the 2.5 is greater. Next one, negative 0.03 and negative 0.3. Okay, I'll draw a number line for this one. Careful here, guys. This says 3 pennies negative. This one says 30 cents negative. So if this is 0, okay, negative 0.03 will be right here. Okay, and if this is 1, let's make that 1. And then the 30 should be about here, 0.3. Okay, so who is greater? The number on the right. In this case, this is the number on the right. So the number on the right will always be greater. Okay. Negative 4.67 and negative 1.23. 4.67 is less. If you draw a number line, if that's 0, this would be negative 1.23, and this would be negative 4.67. And again, the number on the right is always the bigger one. So in this case, negative 4.67 is the lower number. Okay, 7.89 and 7.9. That says $7.89, and the other one says $7.90. You can even add a 0. So this definitely is less. 0.78 and 0.777. Okay, the trick here is that if you want to make life a little bit easier, there's 3 decimal places here. Add one here. Make that a 3 decimal place number. So 0.780 and 0.777. So 780 is definitely greater. Okay, now you got 4/7 and negative 2/8. Is that what it says? And negative 2/8. Okay. A positive number will always be greater than the negative number. Okay. Next one, negative 13, negative 11. Okay, negative 13 is less than, because if you were to draw a number line, okay, negative 11 will show up first, and negative 13 will show up here. Who is the bigger number? The bigger number is the number on the right. Okay. Next one, 7/12. And 8/15. Take your time here, change both of them to a decimal. Okay, 7/12 becomes, this is about 0.58. Okay, you actually have to do the division. Okay, and the other one, as a decimal, becomes 0.53. Very close. So as a decimal, it's very easy to tell who's greater. So okay, 7/12 is greater than 8/15. Okay. What do we have here? Negative 3 4/5 and negative 3 3/4. Definitely change these to decimals. This becomes negative 3.8. This one becomes negative 3.75. Okay. So let's even up these decimals. Add another 0 here. 2 decimal places. So is negative 380 greater or less than the negative 3.75? Draw a number line if you have. Okay. That was a 0 right there. And this was a 3. Negative 1, negative 2, negative 3, negative 4. Negative 375 would be here. negative 380 will be a little bit to the left. So which is the number on the right? This guy. So the number on the right is bigger. So 380 is less than. Okay. 4/5 and 0.8. If you change 4/5 to a decimal, it becomes 0.8. So these two are equal to each other. Finally, next one, negative 125 and negative 234. By now, you should get the hint that the further in negative numbers, the bigger the number, the smaller it is. So negative 125 is definitely bigger. Is it better to owe $125 or owe $230? $234. Definitely better to owe $125. Okay, so this is definitely the bigger value. It's to the right. Okay. Turning the page over. Explain why that number is not rational. It's not rational because it's a decimal. It's a non-terminating decimal. Okay, or you can just write it's a decimal that goes on forever and ever and does not repeat, and that's key. Because if it did repeat, certain numbers did repeat over and over, it would be rational. Okay. Next one, put the following from least to greatest. Okay, so I will draw a very ugly number line, wavy number line. Yeesh, look. All right, let me go. Let's put 0 over here. And on the positive side, we need a 1 and we need a 2, and negative 1, negative 2. I don't know if we need that much. Okay, so let's take 0. It's right here. Negative 2.2. Negative 5 over 7. Okay, that you have to divide, and that's 0.71. So if this is 0.71, would be about here. And let's call that negative 5 over 7. 1 4/9. Okay, 1 4/9, a little bit less than 1.5. Okay, so divide 4 over 9. Okay, and if you divide 4 over 9, you get 0.44. So as a decimal, 1 4/9, I'll just write it on top. The same thing as saying 1.44. Okay, and it's a decimal that goes on forever and ever, so put a little bar on top. Negative 2 4/5. Ooh, negative 2 4/5, sorry. It's going to be negative 2.80. So right here, negative 2 4/5. Or if you change that to a decimal, that becomes negative 2.8. Okay. And 125. There's a dollar. $1.25 is $1.25, so right here. Okay. Okay, change none. So you start on negative 7, the 7th floor. So if you drop 9, negative 7. So here you are at negative 7. If you drop 9, you're going even lower. Okay, so that leaves you to negative 16. Okay. And then it says a rise of 27. A rise of 27 means from negative 16 to 0 is 16. And you still have 11 more to go. So you end up at positive 11. And then from positive 11th floor, you're all of a sudden all the way down to negative 23. Well, if you're on the 11th floor and you go all the way down to negative 23, you got to go 11 floors to 0 and another 23 floors. So 11 plus 23, 34. So it's down 34. Okay. And down 34. Okay, which leads you to negative 23. Now all of a sudden you're back to negative 1. You're not all the way into positive territory. You're pretty close. So you're at negative 23rd floor. You want to go to negative 1, so you got to go up 22. Okay, so let me just write this. None. You're at negative 7. You drop 9, or you go down 9. You end up at negative 16. Okay, and then it says negative 16. If you rise 27, you go to plus 11. Okay, and in order to go from 11 to negative 23, you have to drop 34. Okay, and then from negative 3 to negative 1, you're definitely going up. You go up 22. Okay, and Okay, sorry. I'm going to skip the better deal just for a second, and we're going to do the ones at the bottom. Okay, so you got two choices here. Negative 2.5 is less than negative 4.9, which is less than negative 1. That says that's April. And May says negative 4.9, negative 2.5, and negative 1. Okay, you want to know who's correct? Well, May is correct. How do I know? Well, the easiest way to find out, guys, to do is actually plot those three numbers on the number line. Okay, let's make that 0, negative 1, negative 2, negative 3, negative 4, negative 5. Negative 2.5, okay, so let's make that negative 2, negative 4. So negative 2.5, okay, let me label all of them. Negative 2.5 would be about here. Negative 4.9 would be about here. And negative 1 is right here. So from left to right, did I just say left to right? Left to right, the order from least to greatest would be negative 4.9, as you're reading from left to right, and then negative 2.5, and negative 1. Remember, as you're going right, your value is increasing. So negative 4.9 is less than negative 2.5, which is less than negative 1. There. You can use this number line to prove your point. Okay. Next question. Draw a number line. There are actually going to be a lot of different answers here. It depends on how you want to do this. So 0, 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4, negative 5. So it says start with the integer negative 2 on the number line and label it P. So right on top of negative 2, let's call that P. Okay? So let's go to our first set of instructions. It says locate A, which is the opposite of P. Well, the opposite of P, which is negative 2, would be positive 2. So we'll call that A. Well, the opposite of negative 2 is 2, and we'll call that A. Check. And then label point B, a number less than P. Well, a number less than P, it's not going to be negative 1, 0, 1, 2, 3, 4. So number less than P is either going to be negative 3, negative 4, negative 5. Let's just, for example's sake, pick negative 4. We'll call that point B. Okay, so you could have picked negative 3 or negative 5 as well. And then it says locate point C, a number greater than P. So you're looking, here's your P, greater than this number right here, but less than 0. The only available integer in this case is negative 1, and we'll call that C. So C is greater than P, but less than 0. So that's about it. Okay, let's go back to the better deal problem. Okay, so you have three sizes, brand A, B, and C. A is $7.68 for 32 ounces. B is $10.56 for how much? 48 ounces. And we have C, which is 128. Nope. C is $24.32 for 128 ounces. So you want to find the better deal. Okay, so you're going to divide each here, this one by 32, this one by 32. Okay, if you divide 7.68 divided by 32, this one will give you, okay, and I'm going to write the answer here, 7.68. So at the bottom here you get 1 ounce, and 7.68 divided by 32 is 24 cents. So for this one, the unit price is 24 cents. This one, divide by 48, and divide the top by 48 as well. And you're going to get that 48 divided by 48 is 1 ounce, or 10.56 divided by 48 should give you 22 ounces. No, I'm sorry, 22 cents per ounce. Okay, and here you're going to divide top and bottom by 128. Okay, at the bottom, 128 divided by 128 is 1 ounce, and 24.32 divided by 128 will give you 19 cents. So the best deal here is this guy. 1 ounce of, what is this, apple juice is 19 cents. Okay. Okay, that wasn't that bad. Pretty fast. I will upload it. It's 6:35. It should be up there in about 20 minutes. Let's stop this.